Hello viewers, you are welcome to my class. In today's tutorial today, we are going to be looking at this challenging mathematics question. So we have what we have the question log sine x to base cos x plus log cos x to base sine x equals to 2. So therefore, we want to solve this problem. So what are we going to do? I would like you to stay focused and see what we are going to do. So now you remember from the law of logarithm, you have a property called what? Change of base. So we are going to be using change of base here because if you look at the two bases, you can see that they are not equal. So therefore, we make them to be one base, that is equal base. And we have this property stated as what? As this, we have log b to base a equals to, now like taking the reciprocal of what? Of this 1. So you can see that as we have 1 over, you can see that a and b, their positions are interchanged. Are you getting it now? So the same thing we are going to do here. Okay, so I would like to look at this second term. That is, we are going to be having log sine what? Sine x cos x, then plus 1 over log what? Log sine x, then cos x equals to what? Equals to 2. Is that understood? So now, so from there, so the next thing we are going to do, we can see that we have the bases equal now. So now what we are going to do, so we let what? We let log sine x to base cos x to be equals to a particular constant to be k. Are you getting now? So if this is k, so we can see that anywhere we see, this log sine x cos x from this equation, we need to replace it by what? By k. Are you getting it now? So therefore, we are going to be having what? We are going to be having k plus 1 over k, okay, equals to what? Equals to 2. So this implies that multiplying through by k to clear out the fraction, we are going to be having k plus 1 over k equals to what? 2k. So this is going to be what? This is going to be k square plus k. Then let me send this 2k to the left hand side. I'm going to be having minus 2 what? Minus 2k. This will be k over k. Okay, that is k times k, we have k square. K times 1, we have k over k, then equals to 0. So this implies that k squared plus what? Plus k minus plus 1, okay, minus what? Minus 2k equals what? Equals 0. Are you getting it now? So from there, so we are going to be having, rearranging the equation. So we are going to be having k squared minus 2k plus what? Plus 1 equals what? Equals to 0. So therefore, we are going to factorize this. So now factorizing this, what are we going to have? We are going to have in this way. This is going to be in this form. So we have k here, we have k here. We are going to look at the two factors of what? Of 1. That is when we multiply them together, we are going to have what? We are going to have plus 1. So that is minus 1 and what? And minus 1. So minus 1 and minus 1, that is minus 1 times minus 1. I'm going to have what? I'm going to have plus 1. Then minus 1 plus minus 1, I'm going to have minus 2 here. So equals to 0. So I have what? I have the solution, or the factor to be what? This, which implies that k minus 1 equals to 0. Then we have k to be equals to what? We have k to be equals to 1. So therefore, since k equals to 1, so don't forget that we are actually not looking for what? For k. What we are looking for is what? Is x, that is our variable. So therefore, we need to recall that k is equals to log sine what? Sine x to base cos x. So therefore, since k equals to 1 here, so this implies that k log what? Log sine x cos x equals to what? Equals to 1. Are you following? So now from there, I'm going to have what? I'm going to have this to be in what? To be like this. So this one can actually be written from the law. I get now from the law of what? Of logarithm. So log sine x can be log cos x. That is, this can actually be in this form. Is that understood? Then equals to 1. So down from there, so now when we try to cross multiply, you're going to be having log sine x equals to what? Log cos what? Cos x. Are you getting it? So now from there, so we have what? We have sine x, okay, to be equals to cos x, because we have log here and we have log here. So now from there, so the next thing we are going to do is that if we divide through by cos x like this, are you getting now? You can see that this is going to cancel this. So this implies that sine x over cos x equals to what? Equals to 1. So now recall from the trig identity that tan x equals to what? Sine x over what? Over cos x. I want you to remember that from what? From trig identity. Therefore, this is going to be tan x equals to what? Equals to 1. Do you understand now? So we try to what? To solve this further. So therefore, we are going to be having to be x equals to tan inverse of what? Tan inverse of x. And we know that the tan inverse of 1, rather, the tan inverse of 1. Okay, so the tan inverse of 1 is going to be what? 45 or 45 degree. So therefore, we have one of the values of what? Of x to be 45 degree. So now, let's look at the corresponding values of degree in other quadrant. Let's say we have the quadrant like this. Okay, so now from here you can see that here all the trig ratios are positive here. So we have what? We have this place to be sine is positive here. Here we have what? We have this place cos to be positive here, and we have what? And we have this place to be tan. That is, tan is the only tangent that is, or that is positive here. So now from here, so you can see that the 45 degree we got here is coming from the first quadrant. Are you getting that? And it's positive. Okay, so therefore we are now going to look at the what? We can see that here also we have tan to be positive here. Okay, so therefore we are now going to look at the corresponding values of what? Of this 45 degree in the what? In the third quadrant. So now this third quadrant here. So therefore this is going to be s equals to 180 degree plus what? 180 degree plus 45 degree, and we are going to be having 200 and what? We are going to be having 225 degree. So therefore we have the two possible values of what? Of x to be 45 degree or what? 225 degree. So if you want to know whether the solution is correct or not, so you can plug in these values back to the what? Back to the given equation up there and see whether they are satisfied or not. Thank you for watching. Bye.